Hello, today we're going to be looking at paper 2 of the mathematics AS level. This was a paper that was written in 2021, and let's get into it. So as always, before you start answering any of the questions, make sure you read the instructions so that you are sure to follow them as you answer the question. So this paper, like paper 1, has formulas provided. So if you forget something or are not quite sure, refer to the last couple of pages and you will see the formulas over there. Right, so today I have my calculator with me there so that you can see what I'm pressing. I noticed that a lot of you have problems using your calculators. So hopefully when you see me and how I press the stuff on the calculator, it'll be easier to follow. Okay, let's get into it. Question number 1, it says a polynomial is 2x cubed plus mx squared plus nx plus 5, where m and n are constants. This polynomial leaves a remainder of 45 when it is divided by x plus 2, and leaves a remainder of 21 when it is divided by x minus 2. Find the values of m and n. Now, to solve this one, you just have to make use of the factor and remainder theorem. And the way this works is this polynomial, you're going to call it f of x. This is equal to 2x cubed plus mx squared plus nx plus 5. Okay, so you call your polynomial f of x. Now, what you do is you see this is what it was divided by. So what I do is I say x plus 2 is equal to 0. Then I solve for x. This means x is equal to minus 2. Now, because when this function f of x is divided by x plus 2, that I get a remainder of 45. That means when I substitute negative 2 into this function here, my answer is going to be 45. So I say f of negative 2. This is going to be equal to 45. This is basically what the remainder theorem says, okay? And this 45 will also be equal to this function here when I substitute negative 2 in place of x, okay? So this is my remainder theorem. Then we also know that when it's divided by x minus 2, so x minus 2, I'll equate it to 0. Then I say x is equal to 2. So when I divide it by x minus 2, my remainder is 21. So these are the two equations I will come up with, and then I'll solve them simultaneously to find the value of m and n. Okay, so I start with f of minus 2. That means wherever I have x in the function, I'm going to replace it with minus 2. So I have 2 times minus 2 to the power of 3 plus m times minus 2 squared plus n times minus 2 plus 5. Now this one on your calculator, be sure to type it in exactly the way it is. This 3 must not be inside the brackets, otherwise what you will get will be different. So let's see how you would do it. You have 2, open bracket, negative 2, close your bracket, and then power of 3, shift, like that. So press equal to, that will give you minus 16. So this one here is minus 16. And then this one here, minus 2 squared. Do it in the same way, bracket, negative 2. Close your bracket and then squared. This is equal to 4 times m, of course, because I can't have my m on my calculator. So this is 4m. But such small calculations, you don't need to do them on a calculator. And then n times minus 2, this is minus 2n plus 5. And remember, f of minus 2 is equal to 45. So I'm going to focus on this part of my equation and then write my equation in terms of m and n. All right, so when I do that, minus 16 and 5, I can add them together. So minus 16 plus 5, that is 11, minus 11. Then plus 4m minus 2n, this is equal to 45. And then this minus 11, you take it to the other side and it becomes positive. So what I will get is 4m minus 2n. This is 45 plus 11, which is 56. So this is going to be my first equation of the two that I will solve simultaneously. Okay, the second one is this one here, where I'm going to substitute 2 in place of x and then equate it to 21. So I have f of 2. That means wherever I have x, instead of x, I put 2. So I have 2 times 2 to the power of 3. Now here, because 2 is positive, it doesn't matter that the cube is inside the bracket. Only when it is negative, then you have to make sure that the cube is outside the bracket. Then we have m times 2 squared plus n times 2 plus 5. So this one here will give us positive 16. 2 cubed is 8. 8 times 2 is 16. And then 2 squared is 4. 4 times m is 4m. And then 2 times n is just 2n. Then 5. And remember, f of 2 is equal to 21. So this is 21. So again, this one here is what I'm going to focus on. So we have 16 plus 5, that is 21. I have 21 plus 4m plus 2n is equal to 21. Then this 21, we take it to the other side, it's going to become negative. So on the right-hand side, I have 21 minus 21. This means I have 4m plus 2n is equal to 0. And this is my second equation that I have to use to solve these two simultaneously. Now, the way you solve it is really up to you. You know, elimination, substitution, or by graphing. I think elimination will work very nicely here. So that's the method that I'm going to use to solve these two equations simultaneously. Sorry, I labeled this 1 and 1, but this should be equation 2. So now we solve equation 1 and 2 simultaneously. Okay, so I'm going to use elimination like I said. If the question is not specific, you are free to use whichever method you feel most comfortable with. So if substitution is what you prefer, then go ahead and use that. But if you do it correctly, in the end, we should get the same answers. Okay, so elimination, I'm going to eliminate the m first. So I need to make sure that the coefficients are the same. So this one is a 4, that is also a 4. That's fine. And because the signs are the same, this is positive 4 and positive 4. So when the signs are the same, we subtract. So I say 4m minus 4m, this is 0. Negative 2m minus positive 2m, that is negative 4n. And then 56 minus 0, this is just 56. So now I have negative 4n is equal to 56. We want to solve for n. We divide both sides by negative 4. So I'm over here, negative 4 and negative 4. This means that n is equal to, can do that on our calculator, we have 56 divided by 56 divided by negative 4. This is negative 14. So n is negative 14. And I'm going to use elimination again to solve for n. Once you get one of the values, you can then use substitution, but I just prefer to use elimination. So I write the equations again for m minus 2n. This is 56. And for m plus 2n is equal to 0. Okay, so now, just highlight this one. Now I'm eliminating n so that I can solve for m. So I look at the coefficients, they're both 2. Now the signs are different. When the signs are different, one is positive, the other is negative, what you need to do is add. So you say 4m plus 4m, this is 8m, and then negative 2 plus positive 2, that gives us 0, and 56 plus 0, this is just 56. So from there, we take this equation here. So I have 8m plus 0 is just 8m. This is equal to 56. And then we divide by 8. These two cancel. And then we get m is equal to 7. So you don't need a calculator for that. You should know your times table. So that is basically how you solve this question. Question 1b is they solve this equation here. So the way we solve this one is a little bit similar. We are going to use the factor and the remainder theorem. So first, our equation, we're going to call it f of x. This is 6x cubed minus 5x squared minus 3x plus 2. Now, what we want to do is we want to find a factor of this function. Now, we know that if a number is a factor of another, the remainder is 0 when you divide, okay? So with the previous question, the two terms that we divided by, they were not factors because the remainders were 21 and 45. So the remainders were not 0, that means they were not factors. Here, we want to find a factor, so we want to find out what can I substitute, what value of x can I put here so that the answer is equal to 0. That would mean that the remainder is equal to 0. Now, someone would think, okay, randomly substitute any numbers that will go in there and see if it will work. That might take you a long time. The way to go about it, actually, the easiest way to go about it is you look at the last number, the last digit that you have there. This is 2. Now you start by substituting the factors of 2. So that's 1 and minus 1, 2 and minus 2. Usually those will give you the number that you're looking for. And of course, your calculator, you can do it very easily. I'm going to show you how to do it. So what you do is you're going to type this in on your calculator exactly the way it is. So we have 6, then alpha x to the power of 3 minus 5 alpha x squared minus 3 alpha x plus 2. Okay, then you press calc here, and that means it's allowing you to substitute different values of x into the function. So let's say I substitute x is equal to 0 and press enter. The answer is 2 because you can see if x is 0, this is 0, 0, 0, and the answer is 2. Then I can try another one. You just press calc here, and let's say if I substitute 1. Okay, so when I substitute 1 here, the remainder or the value that I get out of here is 0. So that means that x equal to 1. When I substitute x equal to 1 there, I get a remainder. Then that will tell me what my factor should be. So what I do is I now write it like this. So f of 1. So I checked on my calculator and I got 0. So this is 6 times 1 cubed minus 5 times 1 squared minus 3 times 1 plus 2. So you can type this in on your calculator. You'll see that this is 6 minus 5 is 1, minus 1 is minus 2, minus 2 plus 2, that is 0. Okay, let me say that again. This is 6. No, let me write it out. This is 6 times 1, because 1 cubed is 1, minus 5 times 1, and then minus 3 plus 2. 6 minus 5 is 1. 1 minus 2 is, sorry, 1 minus 3 is minus 2. Minus 2 plus 2, this is equal to 0. Okay, so what did I do? I substituted x is equal to 1. Then this means that x minus 1 is a factor. Okay, so first I write x is equal to 1 because that's the one I substituted. And then I take the 1 to the side where the x is. And then I say that that is equal to my factor. So you don't need to write is equal to 0. Okay, now that I found my factor, what I'm going to do is I'm going to use long division. So long division, write our long division symbol like this. We have x minus 1. And then my function f of x, 6x cubed minus 5x squared minus 3x plus 2. And we're going to perform long division the same way we did if these were numbers over here. So if these were just numbers, you say what I have here, what I have there, you say what I have here, you divide it by that one, you get an answer, you put it up here, then you multiply, and then you write it down here, you subtract, and then you keep going until you get a remainder. So the idea is the same over here. So I start with 6x cubed and I divide it by the x. Okay, so for the first couple of ones, I'll write them over here just to show and illustrate what I'm doing. So I say 6x cubed divided by x. This gives me 6x squared. So you can see the x's cancel, so I have x squared there. Now this 6x squared, what I do is I write it up here. So this is 6x squared. Then as soon as I write something up here, I must multiply it by these two terms over here. So I say x times 6x squared, this gives me 6x cubed, and then negative 1 times 6x squared, this is negative 6x squared. And then whenever I write something down here, what I need to do is I'm going to subtract. Okay, so 6x cubed minus 6x cubed, that is 0. So when it's a 0, you don't need to write it. And I have negative 5x squared minus negative. So don't forget this minus here. That's why it's important to write it. So it's negative 5x squared minus 6x squared. This is positive x squared. And then here I just have zeros. So I have negative, you can write it as, okay, it's not going to let me write it now. So you can write it as 0x, but even just as 0 is fine. So what you do is you say negative 3x minus 0. This is just negative 3x. And then 2 minus 0. This is just positive 2. Okay. Right. And then you continue. So continuing in this way, I will say x squared. I'll divide this by x. So this is just x. Then I write the x on top. So it's a positive x, so I write plus x. And then as soon as I write something up, I must multiply it by these two terms here. So I say x times x, this is x squared. And then minus 1 times x, this is minus x. Then I must subtract. X squared minus x squared, that is 0, so I don't need to write a 0. Negative 3x minus negative x, this is negative 2x. And then 2 minus 0, so remember there's a 0 here. 2 minus 0, this is just positive 2. And then you continue. You say negative 2x divided by x. So we're always just dividing by the first term here. And this gives us negative 2. So the x's cancel. So I put my negative 2 up there. And then I multiply x times negative 2. This is negative 2x. And then negative 1 times negative 2. Negative and negative gives me a positive. And then I subtract. Negative 2x minus negative 2x, that is 0. 2 minus 2, this is also 0. And whenever you divide a function or a polynomial by its factor, the remainder must be equal to 0. So just like when I divide 100 by 2, the remainder is 0 because 2 is a factor of 100. And this is how you know that what you did up here is correct, because you're getting a remainder of 0. Now, what you do, because we're asked to solve this equation over here, what we're doing now is just helping us to factorize. So I have my my long division over here. So I write it again. I have 6, or I write it like this, 6x cubed minus 5x squared minus 3x plus 2. This is equal to 0. Now, when I do long division, if I were to do it, let's say 2 and then 100 here, 100 divided by 2, then I get 50, something like that, 0. I know that I can always write 100 is 2 times 50. So I take this term here and that term they multiply, that must give me this value over here. So the same thing applies over here. If I multiply this number, this term here with this term here, it must give me that one there. So this polynomial here, I can write it as x minus 1 multiplied by the term that I have up here. So this is 6x squared plus x minus 2. And because these two are equal, they are both equal to 0. Okay, so if I look at this second bracket here, this is just a quadratic trinomial, and we know how to factorize quadratic trinomials if they can be factorized. You look at this number 6 and minus 2, you multiply them together. So you say 6 times negative 2, this is negative 12. So you look for two numbers. When you multiply them, the answer is negative 12, and when you add them, the answer is positive 1. So the two numbers, so we say that when we multiply them, the answer is minus 12, and when we add them, the answer is positive 1. So that is 4 and negative 3. So when I multiply 4 and negative 3, I get negative 12, and when I add them, my answer is positive 1. So what we do is this positive 1, we're going to split it into 4x and minus 3x. So from here, I have the x minus 1 bracket. We leave it unchanged for now. Then we have 6x squared, and then the x, we write it as 4x minus 3x minus 2. This is still equal to 0. And then we factorize, we look at these first two terms. What do they have in common? 2x. These two, what do they have in common? Minus x. So my first bracket still remains unchanged. In the second bracket, we say that 2x is a common factor, so we take that out. Then we say 6x squared divided by 2x. This is 3x. And then 4x divided by 2x. This is 2. And then this last two terms, minus 1 is a common factor. So we take out minus 1. You don't even need to write the 1 there. I'm just emphasizing what I'm saying. So you say negative 3x divided by negative 1. This is 3x. And then negative 2 divided by negative 1. This is positive 2. And now you can see that this bracket here and that one there is also a common factor. So we factorize again. So we'll have x minus 1. And then 2x, this minus 1 here, and then this bracket there. I have 3x plus 2. This is equal to 0. Now, the zero product rule says that if you multiply any number of terms together and the answer you get is 0, that means one of them at least must be 0. So this would mean that x minus 1 is 0, or 2x minus 1 is 0, or 3x plus 2 is 0. So if x minus 1 is 0, this means x is equal to 1. If 2x minus 1 is 0, this means that 2x is equal to 1, and therefore x is equal to a half. And then if 3x plus 2 is equal to 0, this means that 3x is equal to minus 2, and then x is equal to minus 2 over 3. So these are your 3 solutions. Okay, and now we can always test our answers and see if what we got is correct. So you can see I still have my formula up there on the calculator. I can press calc. You know that when x is equal to 1, it gives me 0. Then again, calc, let's say I'm using x is equal to half now. So I press 1 over 2. It also gives me 0. Then I try substituting another value. So it's asking me x is equal to what? What x do you want to substitute? I put negative 2 over 3. And it also gives me 0. So I know that what I have done is in fact correct. Okay. Let's move on to the next question. The next question is an integration problem. So we have to find the definite integral of 8 over 2x plus 1 and show that that is in fact equal to ln of 81. So this one, not very difficult to do. So we have the definite integral from 1 to 4 of 8 over 2x plus 1 dx. Now, what we know is that any constants we have over here, they can always go out. So this 8 can go out. This is the integral from 1 to 4. And then here I have 1 over 2x plus 1 dx. Now, the rule of integrating a fraction where in the denominator you have a linear polynomial, that means the highest power of x is 1. The rule is the integral. Let me just write that. If I have ax plus b dx, this is just ln of ax plus b, and then you divide by a, and of course you must add your constant of integration if this is an indefinite integral. Okay, so as long as the highest power of x in the denominator is 1, then the integral is just ln of the denominator, and then you divide by the coefficient of x, and then add your constant of integration. So even with this one, I would do it in the same way. The 8 that is outside would remain there, and because this is a definite integral, I'm going to put my answer in a box to show that I still have to substitute after I integrate. So this will be ln of the denominator, and then divide by the coefficient of x, which is also the derivative of 2x. So it's 2. And then you don't need to add the constant of integration because this is a definite integral. So this is how you would write it. Then what you do now is you just substitute. And even before that, this 2 here can go outside. So you'll have 8 over 2, then ln of 2x plus 1. And then we're going to substitute 4 and 1. 8 divided by 2, this is 4. Then we have ln of 2x plus 1. And then 1 to 4. Okay, so now I'm ready to substitute my values. So I'm going to move it all the way over here just so that I have enough space. This is 4. Then ln, you substitute the number on top first. So this is 2 times 4 plus 1 minus ln, this number at the bottom, 2 times 1 plus 1. Okay, so this is 4. Here we have ln. 2 times 4 is 8. 8 plus 1 is 9. And then the second one, 2 times 1 is 2 plus 1. This is 3. So I have ln of 9 minus ln of 3. And now remember your laws of logarithms. If the bases are the same and you are subtracting, then you can divide the arguments. So this is 4 ln of 9 divided by 3, which is 4 ln of 3. 9 divided by 3 is 3. And again, the laws of logarithms say that if you have a term multiplying your logarithm, this term outside here can be included in the logarithm as the exponent of the argument. So this is ln of 3 to the power of 4. And we know that 3 to the power of 4 is 81. So this answer is equal to ln of 81, as I was asked to show. Okay, question 3. Solving inequalities that involve absolute values. So with this one, pretty straightforward. You just need to remember that absolute values, we are just measuring the distance that a number is away from 0. So if I say, what is the absolute value of 5? What I'm really asking is, what is the distance from 0 to 5? And the answer is 5 units, because our distance is always positive. In the same way, if I say, what is the absolute value of -5? The answer is 5, because it's 5 units away from 0. It's just on the left, and our distance is always positive. Now, with this one here, when we have absolute value is less than another absolute value, what we do is this term here on the right, we'll put it in the middle without the absolute value symbols. So we have 3x plus 3, and then on the right, we will take this equation here without the absolute values, but make it negative. So I say negative x plus 5. And then here on the right, I'll write it as it is without the absolute values, and it would be positive. Okay, so we're saying that 3x plus 3 is between negative x plus 5 and positive x plus 5. So what we do with this, to solve these, we would break it up into 2 inequalities. The first one will be negative x plus 5 is less than 3x plus 3, and 3x plus 3 is less than x plus 5. Okay, so we use the word and here because it must be greater than this, the term in the middle, and it must be less than this. So we don't use the word or here. Now, solving this inequality is pretty simple. First, this minus 1 must multiply out. So we have minus x minus 5. This is less than 3x plus 3. And here, there's nothing to do, so I'm going to focus on this one, solve it until the end, and I'll come back and solve this one. So with this inequality, just like we do with equations, we want all the terms with x on one side, the terms that don't have x on the other side. So I have minus x, I'm going to subtract 3x, so the 3x will come this side, so I have minus x minus 3x, and then this minus 5 will go to the other side. The 3 is going to remain here, and then this minus 5 is going to go over and become positive. So minus x minus 3x, this is minus 4x, and then 3 plus 5, this is 8. Then we divide by minus 4. Minus 4. Now, very important, note that when you divide by a negative number, the inequality must change the direction that it is facing. So anytime you multiply or divide by a negative number, inequality will change the direction that it is facing. So this is x, and then we have 8 divided by negative 4. This is negative 2. So I've solved this inequality on the left, I move on to the one on the right. So again, this x, I want to bring it over. So I'll have 3x minus x. And then this -3, I want to take it over to the other side. The 5 will still be there, and then -3. So what I've done, just like I did here, is collect all the terms with x on the left, and then the terms that don't have an x on the right. Then 3x minus x, this is 2x, and then 5 minus 3, this is 2. And then we divide by 2 on both sides. So I'm dividing by a positive number. So my inequality is not going to change direction. So this is what I have. Okay, it just said solve the inequality. So now we've solved it. So we're saying that this is and. So the word and follows out. So our solution is x is greater than -2 and x is less than -1. So if I was to represent this on a number line like that, I have -2 here and I have 1 here. So from -2 forward and then to 1 go forward. So this is how I would represent it. My solutions are over here. Numbers greater than -2, but less than 1. Another way to combine these two, we'll put the x in the middle, -2 on the left, and 1 on the right. Question 4, a supermarket campaigns to reduce the use of plastic bags. The number of bags N used in a particular week is given by the formula N is equal to 5,000 e to the power of -0.02t, where t is the number of weeks since the campaign began. Sketch the graph of N against t. Now, this is an exponential function, and exponential functions, the way they look, regardless of what you have here, is they will either look like this or they will look like that. So those are the only two ways that they will look. So you just need to decide with this one here, is it going to look like this or is it going to look like that? Now the question is, how do I tell? So this is y is equal to a e to the power of x, and this is the same thing, y is equal to a b to the power of x. And the way they look depends on the b here. So I'm saying x here because of x and y axis, but it can be n on the y-axis and t on the x-axis like we have here. Now, what determines whether it looks like this or like that is your value of b. Now, this one here, this is when b is between 0 and 1. So that means you have a fraction here, let's say half, let's say 1/10, 1/100, and so on. And this one, this is when b is greater than 1. So if you have a b that is greater than 1, then this is what your graph will look like. Now, if we look at this number here, or this exponential term here, just gonna write it there. So we have 5,000 e to the power of -0.02t. So I can rewrite this as 5,000 and then e to the power of -0.02 to the power of t, because we know that laws of exponents, if I have a product, that means it was raised to one exponent and then to another. So if, for example, I have 2 to the power of ab, this is the same as 2 to the power of a to the power of b, or the other way around, 2 to the power of b to the power of a. So here I have -0.02t. It means I first raise it to -0.02 and n to the power of t. So I need to figure out, is this term here in the bracket, is it less than 1 that means it's at between 0 and 1, or is it greater than 1? If it is between 0 and 1, then my graph is going to look like this. If it is in fact greater than 1, then it's going to look like that. So if you're not sure, you just refer to your calculator, press the on button, find E, so alpha E to the power of negative 0.02. I get 0.980, and this is clearly less than 1. It's between 0 and 1, so my graph is going to look like that. Okay, so now that I know what my graph is going to look like, what I do is I'm just going to sketch it. So let me just zoom up a little bit. Let's see. Okay, so I know it's going to look like this one here. I'm going to sketch it. So try and draw this as smoothly as possible, like that. And it continues in that manner. Now we just need to figure out what this value over here is. So remember the t-axis or the x-axis over here is what we call an asymptote. Okay, now an asymptote, that is a line that the graph gets closer and closer to. So you can see it's getting closer and closer to the t-axis, but it never actually crosses it. Okay, so we just need to figure out what is this value over here. And we know at this value, t is equal to 0. So we say that when t is equal to 0, we substitute into this formula there and then solve. So we have 5,000 e to the power of negative 0.02 times 0. So if you're not sure, just type it in on your calculator. So we say 5,000 e to the power of 0.0, sorry, it's negative 0.02 times 0. And you can see the answer is 5,000. So this is equal to 5,000. So this value over here is positive 5,000. Okay, then you would label the equation. This is 5,000 e to the power of minus 0.02 t. Okay, so this is basically all we're looking for when we ask you to draw such a curve. The shape must be nice and smooth. The t-axis must clearly be an asymptote. That means it's getting closer and closer to the t-axis, but never actually crossing it. On this side, it's shooting up to infinity. And the point that it crosses over here, to solve for it, you just substitute t is equal to 0. Okay. Right. Then B says calculate the number of full weeks before the number of the number of bags is halved. Okay, so we have our formula for calculating the number of plastic bags that will be used at a particular time. So the formula is this: N is equal to 5,000 e to the power of minus 0.02 t. Now at time 0, so at time 0, when time is equal to 0, that means at the beginning, we need to find out at the beginning, at the very start of our campaign, how many plastic bags are we using? So we do the same thing that we did to get this 5,000. We substitute t is equal to 0 into this formula. So we say n of 0. That means I'm substituting 0 into the formula of n. We have 5,000 e to the power of minus 0.02 times 0. So I'm not going to type this in again because we worked it out. This is equal to 5,000. So at the beginning, so in the exam, you don't need to put all these explanations because you're not teaching like I'm doing now, but this is just for your understanding. So at the beginning, we use 5,000 plastic bags. So we want to find out when the number of plastic bags will be halved. So half the number, this is just half of 5,000. So half the number is 2,500. So we want to find out when will we be using half the number of plastic bags, or when will we be using 2,500 plastic bags. Okay, so this is what we're trying to figure out. And then what we do is we will equate n to 2,500 and then solve for t. Okay, so we equate n is 2,500 and then solve for t. So in our equation, we have 5,000 e to the power of minus 0.02t. This is equal to 2,500. Okay, so we start, divide by 5,000 on both sides. Then these two will cancel. We have e to the power of negative 0.2t. This is equal to a half. Okay, now we know that when we have negative exponents, we can always write this as a positive exponent. So I have 1 over e to the power of 0.02t. This is equal to a half. And then I can cross multiply or take the reciprocal on both sides. So if I cross multiply, or let me take the reciprocal on both sides. So I have e to the power of 0.02t over 1. This is equal to 2 over 1. So I've taken the reciprocal on both sides. And this means that e to the power of 0.02t is equal to 2. Now I want to get rid of this base e. To do that, I take ln on both sides, the natural logarithm. So we have ln of e 0.02t. This is ln of 2. And this 0.02t will come down from our laws of exponents. So we have 0.02t. This is ln of e, so we'll have this 0.02t ln of e. And ln of e, you can see from our calculator, that is equal to 1. Okay, so that's why I didn't write it. It's equal to 1. Okay, so this is ln of 2. And then to solve for t, I divide by 0.02 on both sides. And this means that t equal to ln of 2 divided by 0.02. So on our calculators, ln of 2 divided by 0.02, and this is 34.657. This is 34.657. But this is to 3 significant figures. I believe that is how the instructions are given on the front page. Now the question says, after how many full weeks? So this is approximately 35 full weeks. Okay, so it's 34 weeks and a couple of days, but we wanted to find out how many full weeks, because that's how the question is stated. After how many full weeks will we have used, will the number of plastics that we use be halved? So it's the actual number is 34 weeks and a couple of days, but we want the number of full weeks. So only after 35 full weeks will the number of plastics that we use be halved. Okay, now 5a, to differentiate. To differentiate this one, we have to make use of the product rule. And as we know, the product rule is if you have two functions of x multiplying and you want to differentiate, you will have to differentiate the first one multiplied by the second one exactly the way it is, and then the first one the way it is multiplied by the derivative of the second one. And this derivatives like ln of x, these are all at the back. So let me just quickly scroll there in case you forget. So these are our derivatives. Okay, so here, like ln of x, you can't remember what its derivative is. It's 1 over x. So you have a table of derivatives that you can refer to. But it's always good to know without having to refer, and then refer just as a backup. Okay, so differentiating this one, I'm just going to write x ln of x minus x. So we say to differentiate this one here, we have to use the product rule. So I say use the product rule. The product rule says the first one is it is, or the derivative of the first one. Doesn't really matter with the product rule in which order you do them in, because you're going to be adding. So let's say I leave x the way it is, and then I multiply by the derivative of ln of x, which is 1 over x. So that's the derivative of this one. Then you add the derivative of x is 1, because x is x to the power of 1. So the 1 will come down. Okay. So you have the 1 will come down. At the top, you have x to the power of 0. X to the power of 0 is just 1. So you have 1 times 1, which is 1. So that's why the derivative of this x is 1. And then you multiply it by ln of x exactly as it is. I haven't differentiated it. And then I move on to this one here. The derivative is minus 1. So it's negative of the derivative of x, which is 1. So simplify x times 1 over x, this is 1. And then 1 times ln of x, this is ln of x minus 1. So 1 plus ln of x minus 1, this is just equal to ln of x. Okay, hence evaluate. Now you can see whenever a question is like hence do this, it means use what you got in the previous step, or somehow include what you did in the previous question to solve this one. Now we know that differentiation and integration are related. So when I differentiate something, I get this. That means if I were to integrate this, I must get that one. So that's how they're related. I differentiate this, I get this. I integrate this, I get that one over there. Okay, so I'm asked to integrate ln of x. My answer must be equal to x ln of x minus x, because when I differentiated x ln of x minus x, the answer is ln of x. So I don't need to do a lot of work there. And this is a definite integral. That means I'll have to substitute these 1 and 2. So the integral from 1 to 2 of ln of x dx, this is x ln of x. So I'm just using the answer over here, minus x. And then I'm going to substitute my points. So this is from A, since integration and differentiation are opposites or inverses. Are inverses. Okay, so that is the reason why. So again, my writing here is not necessarily something that you should write down. It's just because I'm teaching over here. So now we just substitute. So here I will substitute. So I have, wherever I have x, I'm going to put 2 first. So it's 2 times ln of 2 minus 2, then minus 1 times ln of 1 minus 1. Okay, so this will just be 2 ln of 2 minus 2. And we know ln of 1 is 0. So this one here is 0 minus 1, which is minus 1. So I have minus 1. This will be plus 1. So this is 2 ln of 2 minus 1. But even from here, you can type this in on your calculator exactly the way it is. You don't need to simplify it with a calculator before you type it in. So let's do that. 2 ln of 2 minus, sorry, you need to close your brackets because of the way the calculator types it in. Close your brackets. Minus 2. That will be for the first one. Now, if I want to type everything all at once, I need to include brackets here. And brackets there. So I just want to type these brackets that I just put in now are not really necessary, but I want to try and be consistent in what I write here and what I type there. So this second pair of brackets, that one is essential. So it's 1 ln of 1, close your brackets, then minus 1. Okay, so this is 0.386, and I'm leaving this to 3 figures because those are the instructions on the paper. Now, you can always check and see if what you've done is correct. Let's see if we're able to do this, because your calculator can perform some integration. So I say ln of alpha x, close my brackets, then my limit, the lower limit is 1, the upper limit is 2, press equal to, and the calculator will just give you the answer without showing you all the steps. So that's a good way for you to check if what you have done is in fact correct. So you can do it on your calculator. Okay. So question 6, show that the equation sine x plus 60 is equal to 2 cos x plus 30 can be written in the form square root of 3 sine x is equal to cos x. So we're going to use some of our sum and difference identities. Let me see the ones that are provided at the back. Okay, even if they are not provided, I believe you are expected to know them, but here they are. So these are the sum and difference. When you have a plus b, sine of a plus b, it's sine of a, cos of b, plus or minus sine, cos of a, sine of b. So these are the formulas that we will be making use of to simplify and show our expression here. Okay, so let's get into it. Okay. So I have sine of x plus 60 degrees. This is equal to 2 cos of x plus 30 degrees. So the sine rule is sine of x times cos of 60 plus sine of 60 times cos of x. That is how to break this one up. And then on the right, the 2 will be outside. I'm going to open brackets, and it's cos of x times cos of 30 plus minus, sine of x times sine of 30. Now, 60 and 30, these are special angles. If you remember, we have a special triangle to work out their sine, cos, and tan. So I put 30 there, I put 60 there. On this side, okay, this is a 30. Let me just do it nicely. Okay, so this is 30. This is a 60. Okay, so here you have 1, 2, and this side is square root of 3. So cos of 60 Cos is the adjacent over the hypotenuse. So I'll have sine of x times a half. And then sine of 60, this is the opposite over the hypotenuse. So it's square root of 3 over 2. And then times cos of x. Then on this side, the 2 will remain outside. I have cos of x. Cos of 30 is the adjacent over the hypotenuse. So it's times square root of 3 over 2. And then sine of x. Sine of 30, this is the opposite over the hypotenuse. So times a half. Okay, so we can simplify. Here I have a half sine x plus square root of 3 over 2 cos x, and then this 2 here can multiply inside. So the 2 will multiply with this one and cancel. So I'll be left with the square root of 3 cos x. The 2 will also multiply with the half, so I'll have minus sine x. Okay, and then we want to write it in this form where cos x is alone on the right and sine x is on the other side. So this sine x, you can take it to this side. So I have a half sine x plus sine x. And then on this side, I have 3 cos x. So this one has not moved. Then I take this one to that side. I have minus the square root of 3 over 2 cos x. Okay, so a half sine x plus sine x, it's like you're counting how many sine x's do I have? I have half and then I add 1. This will give me 3 over 2. And then sine x. Just like if I have a half x plus 1x, this is 3 over 2x. Okay, so the idea is the same. And then here on the other side, I do the same thing. I have square root of 3 minus square root of 3 over 2. If you're not sure, do it on your calculator. So we have a fraction. In the numerator, we have square root of 3. In the denominator, I have just square root of 3. And then I subtract this fraction, square root of 3 over 2, sorry. Okay, so that gives me square root of 3 over 2. So I have square root of 3 over 2 cos x. Then what I do is I divide by square root of 3 over 2 on both sides. Square root of 3 over 2. So these two will cancel. Then this one here, we have 3 over 2 divided by square root of 3 over 2. We know what happens to our division. It changes to multiplication, and then the reciprocal of this one. These two will cancel. Then I have 3 over square root of 3. Okay, and to rationalize this, let me just write this. This is 3 over square root of 3 sine x. This is cos x. Now we want to rationalize this, or let's rationalize it. So I've squared 3 over the square root of 3. To rationalize it, I'd multiply by square root of 3 over square root of 3. So this would give me 3 square root of 3 over square root of 3 times square root of 3 is 3. And then the 3's will cancel. So this is just equal to square root of 3. So my final answer is square root of 3 sine x is equal to cos x. And this is exactly what I wanted to show. Okay, then B, hence find the acute angle for which sine x plus 60 is equal to 2 cos x plus 30. So you notice this is pretty much the same as the previous one. And when it says hence, again, that's a clue to you that you have to use what you got in the previous question to solve this one. So if I have sine x plus 60, is equal to 2, you have 2 cos x plus 30. This one here, we did it above here. You would just show that this is equal to the square root of 3 sine x is equal to cos x. So I already showed in the previous question that this is in fact equal to that. And now that I want to solve this one here, whenever you want to solve a trigonometric equation that has two ratios, it has sine and cos, what you want to do is rewrite them in terms of just one of the two. Sorry, in terms of one other one. So sine and cos, we can rewrite this as tan. So I'll divide this by sine x. Sorry, I divide by cos x. Then divide by cos x. And we know that tan x, this is sine x over cos x. So we have the square root of 3 times tan x. This is equal to 1. Okay, and then we make tan x the subject of the formula. So we have tan x is equal to 1 over the square root of 3. Okay, so we are only looking for the acute angle, so I don't need to go the route of finding the reference angle and then asking myself in which quadrant is tan positive in, because this is a positive value, and so on. So I just want the acute angle. If the question just said solve this, then you would have to find the reference angle. You'd look at what you have on the right-hand side and say, when is it positive, in which quadrants, and then you would get two solutions between 0 and 360. But here, because the question specifically asks you just for the acute angle, then you would say x is tan inverse of 1 over the square root of 3. So because we want an angle in degrees, make sure your calculator is in degree mode. So on the D there shows you that it is in degree mode, then shift tan inverse, and then 1 over the square root of 3. This is, sorry, so press this button again, and this is 30. So our angle X is equal to 30 degrees. Okay, number 7, we have a parametric equation of the curve. So parametric just means instead of writing y is equal to something in terms of x, what you do is you have x in terms of t and y is also in terms of t, but you would still plot them on the x and y axis. All right, so this curve meets the x-axis at 2 points. Then we have to find the equation of the tangent to the curve at each of these 2 points. So what we need to take note of is when it meets the x-axis, the y value will be equal to 0. So this is the x-intercept. At the x-intercept, y is equal to 0. So we want to find out what are these 2 points. So we have our equation for y. Y is 0. This means that t multiplied by 1 plus t is equal to 0. This means that t is equal to 0, or 1 plus t is 0, which means t is equal to minus 1. So it meets the x-axis when t is minus 1 and when t is 0. And then I can also now find the x-coordinate when t is 0 and when t is 1. So when t is 0, this means that x is equal to, I just substitute there, so I have 2 times 0 squared minus 18 times 0. This is just 0 because everything is being multiplied by 0. And then when t is minus 1, this means that x is equal to 2 times minus 1 here. Because this is negative, my square must go outside, and then minus 18 times minus 1. So here you will type it in exactly as I have it on the calculator. So 2 open brackets minus 1 close brackets, and then you square, then minus 18 open brackets minus 1. Okay, so this gives us 20. So my 2 points where it meets the x-axis are 0, the y-coordinate, sorry, the x-coordinate, and then the y-coordinate is 0. And the x-coordinate is 20, and the y-coordinate is 0. These are the 2 points. So I'm connecting the x and y, x and y. So I know y is 0, then I solve for x, and then I pair them. So these are my 2 points. Now I want to find the equation of the tangent to the curve at each of these 2 points. So what we know is that start with the tangent. Okay, so to find the equation of a tangent or any line, we need the gradient. So the gradient, I'll start the gradient of the tangent, m. This is equal to the derivative of y with respect to x. Now, because these are parametric, the formula we use for finding dy dx, when x is in terms of t and y is also in terms of t, this is dy dt divided by dx dt. So this is the formula you use. Differentiate y with respect to t, and then also differentiate x with respect to t, and then you divide. Okay, so I need to work out dy dt and dx dt. Okay, so y is t multiplied by 1 plus t. So I'm going to multiply this out so it's easier for me to differentiate, and I don't want to use the product rule. So this is t plus t squared. And now I find dy dt. This is 1 plus 2t. And then x, the formula, this is 2t squared minus 18t. So that means that dx dt, this is 4t squared minus 18. Okay, so now I have my dy dt. There. Okay, just so I don't write in the margin as the instructions show. Okay, that looks. Okay, right. Now I'm going to find the gradient dy dt. Okay, so we say that dy dt is given by this formula over here. So I take dy dt is 1 plus 2t, and then I divide this by dx dt. which is 4t. So this should not be a square here. It's just 4t. Now we have 4t minus 18. So this is the formula for the gradient, and I can work out the gradient at each of these points when t is 0 and when t is minus 1. So remember, when t is 0, the x-coordinate is 0, the y-coordinate is 0. When t is minus 1, the x-coordinate is 20, and the y-coordinate is 0. Okay, so I have a formula for my gradient. Now I start with the first point when t is 0. So my gradient m, which is dy dt, dy dx, sorry. So same thing over here. This is not dy dt, this is dy dx. Okay, so I've divided the one on the top, I say it was dy dt. The one at the bottom, this is dy dx t. Okay, so I divided this one, divided by that one, that gives me this. Okay, so this is dy dx when t is 0. So I'm just going to substitute t 0 here. So I have 1 plus 2 times 0 over 4 times 0 minus 18. And this is negative 1 over 18. This is negative. Okay, so now that I have my gradient and I have a point that lies on the line, so the point, this is my gradient. So I have my gradient is negative 1 over 18, and then the point is 0, 0, because when t is 0, we got the y-coordinate as 0, the x-coordinate is 0. Then we can just substitute in the formula y is equal to mx plus c, solve for c, and then write out the equation. So I will have 0 is equal to m minus 1 over 18 times 0 plus c. So here you can see that c is 0, and therefore the equation is y is equal to minus 1 over 18x plus c, which is 0. So that's one way to do it. Another way to find the equation, because we have to work out for the other point as well, when t is minus 1, we can use what we call the 1-point gradient formula. So we need our gradient m. To find the gradient, we are going to substitute minus 1 here. 1 minus 2 times minus 1 over 4 times minus 1 minus 18. So this one, I'm just going to type it in and calculate exactly the way I have it. So I have a fraction, 1 minus 2, and then bracket minus 1. In the denominator, I have 4, open bracket, minus 1, minus 18. Okay, so this is minus, okay, why do I have minus here? Sorry, this should be plus. That's a mistake, so this should be a plus. Okay, my answer is 1 over 22. So here I should have a plus because that's the formula there. So it's a plus here. Okay, so this is 1 over 22. So I have my gradient and my point is 20, 0. So the 1-point gradient formula looks like this: y minus y1 is equal to mx minus x1. So this is my x1, y1, and this is my m. I just substituted here, and then after that I'll write this in standard form. So this is y minus y1 is 0, m is 1 over 22. Then we have x minus x1, this is 20. So here I have y is equal to, multiply out the brackets, I have 1 over 22x, this times that. This is negative 20 over 22. And yes, we still want to simplify this. 1 over 22x, and then this is 10 over 11. Okay, so that is the equation of the tangent to the curve at those 2 points. So say, therefore, the equation of the tangent is y is equal to 1 over 22x minus 10 over 11. Right, 8a, show that the equation x cubed minus 4x minus 2 is equal to 0 has a solution between 2 and 3. To solve this one, you say f of x is x cubed minus 4x minus 2. That is your x cubed. Then what you do is you substitute 2 in here. So you say f of 2. This is 2 cubed. Brackets are not needed here because this is a positive number. And then 4 times 2 minus 2. So this you can do on your calculator. So we have 2 cubed minus 4. You can put times 2 or brackets 2. It's the same thing. Then minus 2. This is negative 2. So you can see my answer here is negative. That's important to take note of. So it is negative. And then I do the same thing, f of 3. This is 3 cubed minus 4 times 3 minus 2. Again, do it on your calculator. So we have 3 cubed minus 4 times 3 minus 2. This gives me 13. And this is a positive number. So that is what we are supposed to take note of. So when I substitute 2 into the function, I get a positive value. And then when I substitute 3 into the function, I get a positive value. So here I get a negative, over there I get a positive. That tells you somewhere between 2 and 3, I must get a 0, okay? Because they don't just jump from negative to positive. Somewhere, some number between 2 and 3 must give me a 0. So this shows that there is a value between 2 and 3, such that f of x is equal to 0. So you can find a value between 2 and 3 that gives you 0, since it changes from negative to positive when you go from 2 to 3. Okay, since the sign of f of x changes from negative to positive, from x is equal to 2 to x is equal to 3. Okay, right. Then B, show that the equation x cubed minus 4x minus 2 equal to 0 can be rearranged in this form. Okay, so this is basically just algebra playing around with the equation. So I have x cubed minus 4x minus 2 is equal to 0. So first thing I can do, if I look at these, the highest power of x is 1 in each of these x's that appear here. So that should tell me I need to divide everything by x. So I can divide by x. So this will give me x squared minus 4 minus 2 over x. This is equal to 0. And then I take these two terms to the other side. So I have x squared. This is equal to, if you take this one first, you get positive 2 over x, and this one plus 4. And now we want to take the positive square root. So x is equal to just the positive square root, 2 over x plus 4. So I'm showing that you can solve for x in this way. So this is basically what we want to see. Then starting with x1 equal to 2, use the iteration method. Xn plus 1 is equal to 2 over xn plus 4 to find x2 and x3, correct to 3 decimal places. So what this means is you are going to find your x2. So if you want x2, you'll substitute 2 over x1 plus 4. Then to get x3, you substitute the value of x2 here and you proceed in this manner. Okay, so x1 is given as 2. So x2, this using just substituting into the formula, I have 2 over x1 plus 4. So this is the square root of 2 over my x1 is 2 plus 4. This is the square root of 1 plus 4, which is the square root of 5. So I want the answer correct to 5 decimal places. So what we do, type this in on your calculator, square root of 5. That we get 2.36507. So x2, this is 2.23607. This is to 5 decimal places. And then I also work out x3. So x3, just substituting in the formula, this is 2 over x2 plus 4. So this is the square root. 2 divided by this value I got here, 2.23607, and then plus 4. So you can type this in on your calculator. Usually we don't like to round off too early, so you can work it out like this. Type it in square root, big fraction of 2, and then here, instead of writing the one that's rounded off, you can put square root of 5, and then plus 4. Then after that, you round it off to 5 decimal places as required. So this is 2.21234. So here, I don't use that one there. I use the exact value, but the difference will not be that big. Okay, so those are my x2 and x3 that I was required to give. Then find the solution to the equation correct to 4 decimal places. So correct to 4 decimal places, I've already found x3, then I can just work out x4. So x4, this is the square root, 2 over x3, then plus 4. This is the square root 2. I'm just going to use this one as I have it, 2.21, 2, 3, 4. So because it's needed correct to 4 decimal places, writing this one, using this one, which is correct to 5 decimal places, is fine. So I have 4. So we type this in on our calculators. Square root fraction 2 over 2.21234 plus 4. Enter. Okay, so this is 2.2145. That is 2 4 decimal places. That's 2. Okay, and this is 2 4 decimal places as required. And you can try substituting it over here. You'll get an answer very close to 0. Maybe not exactly equal to 0 because this is rounded off to a certain number of decimal places. And with such questions, the more iterations you do, the closer the answer is. Okay, then number 9, we have to integrate. With this one here, what we want to do is this denominator included in the numerator. So I will first split up my fraction. So I have 4 over e to the power of 3x minus 2 e to the power of 3x over e to the power of 3x dx. And now I look at this 2 integrals. So I have the integral of 4 over e to the power of 3x dx minus the integral of 2 e to the power of 3x over e to the power of 3x dx. Now notice that these two will cancel because they are the same. And then this one over here, you can bring it to the numerator by changing the sign of the exponent. So this is the integral of 4 e to the power of negative 3x dx minus the integral of 2 dx, because this gives me 1, so I have 2 times 1. The 4 here can go outside. And then minus 2 dx. So I just want to integrate everything at once. So my answer here, this is 4. When we're integrating e to the power of something, so first it remains e to the power of 3x, and then we divide by this number here in front of the x. So we divide by negative 3, and then this one gives 2x, and then we add our constant of integration. So the integral, just remember e to the power of ax dx. This is just e to the power of ax, and then this number here, you divide by it, and then add your constant of integration. So I don't need to add a constant of integration here and there. This constant accounts for both constants. Yeah, now we usually like to leave our answer with positive exponents. So this will give me negative 4 over 3 e, the denominator 3x minus 2x plus c. Okay. By expressing 4 cos squared x in terms of cos 2x, find the integral of 4 cos squared x. So you need to recall, I think this was also part of the list of formulas given at the back of the paper, is that cos 2x, this is 2 cos squared x minus 1. So I can take this minus 1 to the other side. So I have cos 2x plus 1 is equal to 2 cos squared x. And then I can divide by 2 on both sides. So I have a half cos 2x. So here I'm taking cos of 2x. The brackets are not really needed. Plus 1. This is equal to cos squared x. So if I'm integrating 4 cos squared x, so I'd have to multiply by 4 on this side, multiply by 4 on this side. So I would then get 4 times half is 2. Cos 2x plus 1 is equal to 4 cos squared x. So integrating 4 cos squared x dx, this is the same as integrating 2 times cos 2x plus 1 dx. And this is much easier to integrate than that one because we know how to integrate this. So I can multiply out my brackets. This is 2 cos 2x plus 2 dx, and then we'll split up our integral. Just gonna do it here so that I have more space. This is the integral of 2 cos 2x dx plus the integral of 2 dx. Okay, now another thing to take note of is that if you're integrating cos of ax plus b, so this is a linear term, the answer is just sine of ax plus b, then you divide by the coefficient of x, and then you add your constant of integration. So here, this 2 can go outside. So I have 2, the integral of cos 2x dx plus the integral of 2 dx. So this is 2. Following this method here, my a is 2 and my b is 0. This is sine of 2x, and then I divide by the coefficient, that's 2 there. And then the integral of 2 is just 2x. That'll be a 1 divided by 1, then add your constant of integration. Simplify this as far as possible. See that this 2's cancel. So I have sine 2x plus 2x plus c. That is my integral. Number 10. We have the equation of the curve 3xy minus 5y minus 2x squared is equal to 6. Show that dy dx is equal to this. Here we have to use implicit differentiation. So remember that y is a function of x. So when I differentiate x times y, I have to use the product rule. So you must look at it as two functions. The first one is 3x, and then the second one is y. So first I write the 3x the way that it is, and then multiply by the derivative of y. The derivative of y is just dy dx. Then you add, then the derivative of 3x is 3, and then the second function y, you leave it the way it is. That's how we use the product rule to differentiate this one. Then minus the derivative of 5y is just 5 dy dx. Then the derivative of this one, this 2 will come down and multiply with the 2 there. I have 4, and then at the top, x to the power of 1, which is just x. Then on the right-hand side, the derivative of a constant is 0. Now, when you have this, what you want to do is you collect all the terms with dy dx on the left, the terms without dy dx on the right. So we have 3x times dy dx minus 5 dy dx. This is equal to, this one goes that side, so I have 4x. This one goes that side, I have minus 3y. So on the left, you factorize dy dx. So dy dx, you factorize it. So you have 3x, you factor it out, and then here you have minus 5. This is 4x minus 3y. And then you divide by this bracket on both sides. Okay, so they will cancel. Then I have dy dx is 4x minus 3y over 3x minus 5. All right, so that is exactly what we were told to show, and we have done it. Okay, then it says find the equation of the normal at the point where the curve, where x is equal to 1. Now, the equation of the normal, what we need to remember is that the normal is perpendicular to the tangent. And dy dx, this is the gradient of the tangent. And if two lines are perpendicular, it means that the product of their gradients is equal to -1. So I can work out the gradient of the tangent. And I do this by substituting x is equal to -1 into the formula for dy dx. So this is my dy dx. So this is dy dx. And I'm going to substitute x is equal to -1. So this gives me 4 times -1 minus 3 times y. I need the y value. Okay, so something I forgot. We need to get the y coordinate first. So to get the y coordinate, I need to substitute it in there. So I can't go straight to finding the tangent. That's an oversight by me. Okay, so we will still come back and do all this, but first we need to find the point. Okay, so the equation of the line, or the curve, rather not a line, was 3xy minus 5y minus 2x squared is equal to 6. So this is the equation that 3xy minus 5y minus 2x squared is equal to 6. So I'm going to substitute x is equal to -1 here and then solve for y. So say that when x is equal to -1, we have 3 times -1 times y minus 5 times y minus 2 times -1 squared is equal to 6. This is minus 3y minus 5y, and this is minus 2 is equal to 6. Minus 3y minus 5y, this is minus 8y, minus 2 is 6, minus 8y, this minus 2 can go to the other side, we get 8, then we divide by minus 8, minus 8, this means that y is equal to -1. So the point of tangent C or normal C is -1, that's the x coordinate, and we solve for the y coordinate, which is also -1. Okay, now we go back to what I was so eager to do. So our gradient m, we just substitute into dy dx. The x value is equal to -1, and the y value is also equal to -1. So we have 4 times -1 minus 3 times -1 over 3 times -1 minus 5. Okay, so there's my formula. I'm just substituting -1 like that. So this you type in on your calculator exactly the way I have it. So I have 4 open brackets -1 minus 3 open brackets -1. The denominator 3 open brackets -1, then -5. So this is 1 over 8. Okay, so this is the gradient of the tangent. So remember, we're looking for the equation of the normal. So the gradient of the normal, this is just the negative reciprocal of 1 over 8, which is negative 8, because we say that the tangent and the normal are perpendicular. So when I multiply the two gradients together, it must give me negative 1. So negative 8 times 1 over 8 is negative 1. And then I'm going to use the equation y minus y1 is mx minus x1. So my point is minus 1. So this will be my x1, y1. So I have y minus negative 1 is equal to negative 8, x minus negative 1. Simplify, more space here. Okay, so here we have y minus negative 1 is y plus 1. And then this negative 8, we have x plus 1. We have x plus 1. So now we multiply out. So we have y plus 1. This is negative 8x minus 8. And then making y the subject of the formula, we have y is equal to negative 8x. This will go that side and we will get minus 9. Okay, so this is the equation of the normal. So key thing to remember, how are the normal and the tangent related? Okay, question 11. Show that the equation ln of 3 plus 3 ln, ln of 3 plus 2 ln of x minus ln of 2x minus 1 is equal to 2 ln of 2 can be expressed in this form. Okay, let's get to it. Ln of 3 plus 2 ln of x minus ln 2x minus 1 is equal to 2 ln of 2. So we have numbers here multiplying our logarithms. We can include them in the logarithm. So we have ln of 3 plus ln of x squared minus ln of 2x minus 1 is equal to ln of 2 squared, and this is just equal to 4. So this is ln of 3, ln of x squared minus ln of 2x minus 1. This is ln of 4, which I could have done over here. Now on the left-hand side, I'm adding these two logarithms. The bases are the same, so I can multiply the exponents. This one is subtracting. That means I would divide, not the exponents, arguments. So I can rewrite this as ln of 3x squared divided by 2x minus 1. And this is ln of 4. Now, because these two logarithms have the same base, then I can equate their arguments. So I can say 3x squared over 2x minus 1. This is equal to 4. And then multiply, cross multiply. We have 3x. This is 3x squared is equal to 4 multiplied by 2x minus 1. The 4 must multiply out. So I have 3x squared is equal to 8x minus 8. And then we want everything on the left, 0 on the right. So we have 3x squared. This one goes to the other side. You get minus 8x. This one goes to the side. Sorry, here I don't know why I put 8. It should be a 4. Okay, so it's 4 times minus 1. So this is a 4. And when it goes to this side, you get positive 4. This is equal to 0. And that is exactly what we wanted to show. Okay, now Hence solve this equation over here. So you can see that this is similar to this question that we got over here. If you will let 2 to the power of n equal to x. So here you'll have ln of 3 plus 2 ln of x minus, now this one, 2 to the power of n plus 1. You should know that this is 2 to the power of n times 2. So this means x times 2, which is equal to 2x. So if I were to rewrite this in terms of x, I have ln of 3 plus 2 ln of x minus ln, so instead of 2n plus 1, I have 2x minus 1 is equal to 2 ln of 2. And that is exactly what we have over here. And we know that once we have it in this form, we can rewrite it as a quadratic equation like this. So I will just go ahead and rewrite it like this. So this means that 3x squared minus 8x plus 4 is equal to 0. And I will solve this, but then remember that I'm looking for n and not x, because in this question there is no x. So this is a quadratic equation. Want to solve this by factorizing. We look for two numbers. When we multiply them, the answer is 12. And when we add them, the answer is minus 8. So that's minus 2 and minus 6. So I have 3x squared minus 6x minus 2x plus 4. So 0. These first two terms, what do they have in common? 3x. Then I have x minus 2. These two terms, they have minus 2 in common. I have x minus 2 is 0. So we complete the factorization. So 0. Then this means 3x minus 2 is 0, or x minus 2 is 0. This means 3x is 2, or x is 2 over 3. And here x is equal to 2. So those are my two values for x. But remember, I'm not solving for x. What is x equal to? X is equal to 2 to the power of n. So I have 2 to the power of n is equal to 2 over 3, or 2 to the power of n is equal to 2. To solve this one, you can take log base 2 on both sides. Log base 2 of 2 to the power of n is log base 2 of 2 over 3. So here I have n is equal to log base 2 of 2 over 3. So this you type in on your calculator. Okay, log base 2 of 2 over 3. This is negative 0.585 if I write it to three significant figures. So n is equal to negative 0.585 to three significant figures as the instructions say. And then this second one, 2n is equal to 2. We can rewrite this as 2 to the power of n is equal to 2 to the power of 1. Now, because the bases are the same, this means that n is equal to 1. Of course, you can take log base 2 on both sides. That will also work. You'll still get n is equal to 1. Then question 12, express 3 cos theta plus 3 sine theta in the form of r cos theta minus a, where r is a positive number, that means it's greater than 0, and alpha is between 0 and pi over 2. So when our angle here is in terms of pi, that should tell you that the angle is in radians, so it's measured in radians. Okay, so what we will do is we will rewrite this one here. So we write r cos theta minus alpha. Now from our sum and difference angle identities at the back, we see that this is r cos of theta times cos of alpha plus sine of theta times sine of alpha. Okay, so this is the definition. And this, we want to show that it is equal to 3 cos theta plus 3 sine theta. Okay, so what we're going to do is here I'm going to multiply out my brackets and then by comparison solve the two. So I have r, multiply this, I have cos theta, cos alpha, plus r sine theta, sine alpha. This is equal to 3 cos theta plus 3 sine theta. Okay, so what I do is I see this term here has cos theta and this term here has cos theta, so they must be equal. So r cos theta times cos alpha is equal to 3 cos theta. And then this term here has sine theta, and then this term here on the right also has sine theta, so they must be equal. And r sine theta sine alpha is equal to 3 sine theta. Okay, so we can divide both sides by cos theta for the first one. So you divide by cos theta, divide by cos theta, so those cancel. So I have r cos alpha this is equal to 3. And then we do the same thing on this side. Divide by sine theta, divide by sine theta. These two will cancel. So I have r sine alpha is equal to 3. So those cancel. So you can see I have a pair of simultaneous equations. And we're going to solve these by substitution. So here I can make r the subject of the formula or cos alpha. We have cos alpha. Cos alpha is equal to 3 over r. And then the same thing here, sine alpha. This is equal to 3 over r. So these are both equal to 3r. So that means they're equal to each other. So this means that cos alpha is equal to sine alpha. So I'm solving these just by substitution. And then dividing both sides by cos alpha. So divide by cos alpha, divide by cos alpha. Here I'll get 1. And sine over cos, this is tan alpha. Now, because I know that my angle alpha is between 0 and pi over 2, that means my angle is acute. And to get alpha, I will just say tan inverse of 1. Now, again, my calculator is in radian mode. This is one that we should know. Let's see, mode, shift, step up. So I go to radian mode 4. And then I find tan inverse of 1. Okay, and the answer is pi over 4. So this is pi over 4. So very important that your answer is in, your calculator is in radian mode. So how do you know if you should be in radian mode or not? If your angle is given in terms of pi, then it is in radians. Okay, so now that I know what what alpha is, I can work out my r. So here I know that cos, I use one of these, either this one or that one, that will give me the same thing. So I say that cos of alpha is equal to 3 over r. This means that r is equal to 3 divided by cos alpha. But then remember that alpha is pi over 4. So this means that r is equal to 3 divided by cos of pi over 4. So this you can type in on your calculator, but remember your calculator must be in radian mode. So we have 3 over cos of pi. Pi is here, so shift over 4. And then I'm getting 3 square root of 2. Okay, so remember what we wanted to do? We wanted to have our equation 3 cos theta plus 3 sine theta and write it as r cos theta minus alpha. So we just want to rewrite this, except we've solved for r and we've solved for alpha. So we say that 3 cos theta plus 3 sine theta. This is our r. So this, we write it as r cos theta minus alpha. Let me just see, make sure that everything is in fact correct. Okay, so we say that r cos alpha is equal to 3. Then this means r is equal to 3 over cos alpha. Yes, that's fine. Okay, then that's fine. All right. So this is equal to, my r is 3 square root of 2, and then cos of theta minus alpha, which is pi over 4. Okay, then it says, hence find the smallest value of theta satisfying the equation 3 sine theta plus 3 cos theta is equal to square root of 3. So we have 3 sine theta plus 3 cos theta is equal to square root of 2. But this one, we know that we can rewrite it like this. So we have 3 square root of 2 cos of theta minus pi over 4. This is equal to square root of 2. And now we solve this one. So we'll divide by 3 square root of 2 on both sides. So these 2 will cancel. So I have cos of theta minus pi over 4. This is equal to, the square roots will cancel. I have 1 in the numerator. So I have 1 over 3 there. Okay. Then we want the smallest positive value. So we just take cos inverse. So we have cos inverse of cos of theta minus pi over 4. This is equal to cos inverse of 1 over 3. So cos inverse and cos will cancel. So I have theta minus pi over 4, this cos inverse. So remember, we're still in radian mode. So shift, then cos inverse of 1 over 3. This is 0.945 radians. And this is to 3 significant figures as the instructions state. Okay, so that is the smallest possible, the smallest positive value. This would be an angle in the first quadrant. Okay, then B, solve the equation 4 over tan 2x plus 5 is equal to tan x, and we want an angle between 0 and 180. Okay, so we have 4 over tan 2x plus 5. This is tan x. What we do is we can get rid of the denominators by multiplying tan 2x throughout. So say times tan 2x times tan 2x and then times tan 2x. So these two will cancel. So I have 4 plus 5 tan 2x. This is tan x times tan of 2x. And this tan 2x, we can rewrite it in terms of the sum and difference identity. So this is one that we should know. And I believe it's also provided at the back. Let's see. Where is it? Even here it is. This is the formula that we have. So we will use x plus x. So it's tan x plus tan x over 1 minus tan x times tan x. Okay, so formulas are provided, but it's always a good idea to also know the formulas yourself. So tan of 2x, we say this is tan x plus tan x, which is 2 tan x. And then we have 1 minus tan squared of x. This is tan x times 2 tan x over 1 minus tan squared of x. Okay, so here, what we then do is we can multiply out the brackets and then get rid of the denominators. So I have 4 plus 10 tan x over 1 minus tan squared of x. This is 2. So if I multiply the tan x and tan x, I get tan squared of x. This is over 1 minus tan squared of x. Okay, so I can take this one to that side because they have the same denominator. I'll bring this one to that side. We have 4 plus tan x over 1 minus tan squared x minus 2 tan squared x over 1 minus tan squared x. This is 0. So because the denominators are the same, I can add the numerators. And even this one here, I can make it over 1 minus tan squared x. So I have 4 times 1 minus tan squared x plus 10 tan x minus 2 tan squared x is equal to 0, but this is everything is over 1 minus tan squared x. Okay, then to get rid of the denominator, you cross multiply and multiply this out. 4 times 1, this is 4, minus 4 tan squared x plus 10 tan x minus 2 tan squared x. This is equal to 0. Then the tan squared, you can add them together. I have minus 4 tan squared x and minus 2 tan squared x. This gives me minus 6 tan squared x. So I'm just writing them first. And then this is positive 10 tan x. And then the 4 does not have any like terms. Okay. Right, then I can divide everything by minus 2. So divide by minus 2, minus 2, minus 2. We get 3 tan squared x minus 5 tan x minus 2. This is equal to 0. Okay, now this is in fact a quadratic equation. And if you cannot quite see it, you can say let m can be any letter except x. Let m equal to tan x, then m squared is tan squared of x. Then you substitute there, I'll have 3m squared minus 5m minus 2. This is equal to 0. So with this quadratic equation, we can factorize. We look for two numbers. When we multiply them, the answer is negative 6. And when we add them, the answer is minus 5. So that's minus 6 and plus 1. So we have 3m squared minus 6m plus m minus 2 is 0. Factor of minus 3 here. We have m minus 2. And then here we factor out a 1. Then 3m plus 1, m minus 2. And this means that 3m plus 1 is 0, or m minus 2 is 0. Okay, so if 3m plus 1 is 0, this means 3m is equal to minus 1. Therefore, m is equal to minus 1 over 3. Or here, m is equal to 2. Now, let's just go back to the question here. Now, we want a value between 0 and 180 degrees. So because we're dealing with degrees, our calculator must be in degree mode again. Okay, so remember what m was. M was tan x. This is equal to 1 over 3. And this one, tan x is equal to 2. Now, when we're solving these equations, what we need to do is you need to first have it in this form where it's tan x is equal to something. Make it the subject of the formula. Then you find your reference angle. Then you ask yourself in which quadrant is the angle I'm looking for in, and then you take your reference angle to those quadrants. Okay, so we'll have to use this additional paper or additional sheet here. So we start with the first one. It says tan x is equal to minus 1 over 3. So first thing is our reference angle. So reference angle, usually we call the reference angle alpha. This is tan inverse. When you're finding the reference angle, you ignore the negative. Never type in the negative when you're finding the reference angle. So you go to your calculator, switch the mode back to degrees because now we're working in degrees. Press 3. Then we say tan inverse of 1 over 3. So notice I am ignoring the negative, and this gives me 18.4. So 18.4 degrees. Okay, then you look at this number that you have on the right-hand side. So this is a positive number, sorry, not a positive number, obviously. This is a negative number. Okay, so this is a negative number. Then from your cast diagram, you ask yourself, in which quadrants is tan negative in? Tan is negative in the second and the fourth quadrant. So we can find two angles that give us tan of that angle is -1/3. The first one is in the second quadrant, and then the next one is in the fourth quadrant. But remember, from the question, we only want angles in the between 0 and 180. So our only solution will come from the second quadrant. So our solution in the second quadrant, we know that angles x in the second quadrant, we write them as 180 minus the reference angle. So this is 180 minus my reference angle. This is 18.4. This is 161.6. Okay, and ordinarily I would also find the angle in the fourth quadrant, but from the question said we are only interested in angles between 0 and 180, and an angle in the fourth quadrant will be bigger than 180, which is not what we're looking for. Then we go back to the second equation, tan x is equal to 2. So we say tan x is equal to 2. So the same procedure, we need our reference angle. So you say alpha, this is tan inverse. If there was a negative over here, I would ignore it. So I say tan inverse of 2. There's no negative to ignore, so I just proceed. So shift tan inverse of 2. This is 63.4. This is 63.4 degrees. And then I draw my cast diagram. So CAST. And I look at this number here on the right-hand side, it's positive. So I ask myself, in which quadrant is tan positive in? It's positive in the first quadrant and in the third quadrant, but we cannot have our answer in the third quadrant. Why not? Because we're only interested in angles between 0 and 180. That's what the question says. So our only solution must be from the first quadrant. So if x is in the first quadrant, x is just equal to alpha, and x is equal to 63.4 degrees. Okay, so we have two solutions for x. The first one, x is 161.6 degrees and 63.4 degrees. And that is the end of the paper. I hope you found this helpful.